right, I guess we'll get started. A minute 30-ish delay. Yeah, it's kind of annoying. Some people have tried helping me out while I'm coding, and it's like they'll tell me what's wrong, and then I'll figure it out, and then I get that. So, but if I don't figure it out in under a minute 30, then it does help. So definitely appreciate any help. So what we're doing today is continuation of what we were working on last week, which was we have a new branch here. So this is a Glider Labs SSH. It's a library for building SSH servers. Brad Fitz says it's dope. It basically is wrapping this. This is the sort of closest thing to a standard library for SSH, which actually gives you quite a bit. It's just kind of the abstraction is still pretty low level. The SSH protocol is really, it does a lot of things, sort of in a different way than the complexity of HTTP. It sort of functionally does a lot of things. And so that's kind of what we're working on, is one of those extra things that it does. It can do TCP forwarding. And so adding support to this library to support, it's actually already somebody submitted local forwarding, which is significantly easier and overall simpler than remote forwarding. Remote forwarding requires a request to be sent, and then a channel to be opened in the reverse direction, and then how you handle that will kind of be interesting. I haven't really thought about that, but this remote forwarding will be helpful in situations, a very specific situation in which we'll be working on a feature soon for Command IO, which lets you run shell commands in the cloud. It's sort of like a function as a service, but more of a shell command type of thing. And it has one kind of major limitation, which is it only accepts standard in for input. And so doing any kind of command that does any kind of local file system operation, you have to wrap it. For example, LaTeX, you have to wrap it so you pipe in files, maybe multiplex some files using a tar pipe or something, but it has no access to your local files. So in an even previous stream, we worked on I found a 9p implementation in Go, and then we made a 9p Docker volume plugin. So this lets you create 9p. 9p is like NFS. It's just much simpler and straightforward. So it's much easier to work with. It's less finicky. There's less different versions and all this stuff. And we have a nice implementation in Go. And then this plugin lets you use Docker as a way to mount 9p file systems. So the way we're going to implement this in Command IO, which is open source to people that have alpha access, it'll eventually be open source to everybody. But the way we'll implement this in Command IO to solve this problem of the local file system is to create a client that runs a 9p file server, and then when you connect over SSH to Command IO, it will also open a multiplex stream and forward any connections to the 9p server over that TCP that SSH connection. Because SSH is actually a great sort of multiplexing, not ideal, but it is a multiplexing protocol. And so we can use that to send over this 9p data, and with the Docker plugin, when we create the environment for your Command IO command, it would just say, hey, connect to this gateway, and that gateway knows how to connect over SSH back down to your client and get access to your local file system. And it will be awesome, because it means you will be able to create commands in the cloud that will do operations in your current to files in your current directory. So that'll be very cool. So I've been working on a lot of pieces working up to that. And one of the last pieces is having SSH actually do that remote forwarding. So the remote forwarding, there's two parts, a couple parts to it. SSH can open up arbitrary channels in either directory. A channel is like a virtual socket connection. But we're going to have to look at some specs here to make sure that we have this correct SSH protocol. When you do a remote forward, the server side, the client says, hey, I want to expose this port, and then the server side has to say, okay, I'm going to start listening on a port, and then as long as it's listening, it will forward any connections by opening up another channel. So because it has to start listening on a port, it needs this sort of request to say, hey, I need you to start listening on a port or stop listening on that port for forwarding. So besides just opening a connection, it has the SSH has, besides channels, it has requests. So there are global requests, which are just little messages that just sort of like almost like UDP packets, and so they have a let's see what would it be part of, I guess, connection layer. So it would send a request saying, hey, I want to start forwarding, I want remote forwarding, and so then that's when it'll listen. So we had to, in the last one, we mostly set up, this is a project, we mostly, this is also wrong, it's also wrong, okay, I don't even have it open. I recently started actually using my home directory as my Go path. I was doing some symlinking stuff, and there was always some edge case where that didn't work. Okay, and then are we in the right? Oops, are we in the right? Yep. I put a thing out because on the last episode of this, I guess, most of it was kind of figuring out how to get our SSH library to have kind of arbitrary new handlers, but not just for channels, but also requests, because this is the first sort of sub-protocol or module or component of the SSH protocol that actually really cares about requests. Before, we were actually just discarding all global requests. And so we had to create instead of discard them, we actually have to create a handler or a handler router that would basically, any registered handler will send them if they want to, if they implement handle requests. So it's really just like messing with the abstractions to get to a point where we have this, which is kind of ready for us to actually implement what happens, how these things are handled. So that's what we're going to do here, is actually do the implementation. So I guess we're going to have to do some reading to get back into this. See, if you're requesting forwarding from your end to the other direction, you don't have to request it. You can just do it. You can open up a channel. But connections on the remote side, before to the local side, it must request it. So this is TCP forward, and all requests kind of have these fields in the message, and then these are specific to this. And it's pretty easy to handle these. You just create a new struct. This is the one for local forwarding. I think we'll create one for remote forward request and address to bind. I think these are okay. Address to bind, specify IP address and port on which connections for forwarding to be accepted. Some strings used special cases. So empty means that connections are to be accepted on all protocol families. Zeros means listen on all IPv4. I don't know what the short. Does anybody know the shorthand for the IPv6 all? Listen on all interfaces. : we'll just say. Localhost. Okay, note that the client can still filter connections. Sure. Implementation should only allow forwarding privileged ports if the user has been authenticated as a privileged user. So this is one of those things where we might have to provide a callback or just not do anything about this. Although it should, I guess, sort of, yeah, it would basically, however the daemon is run, yeah, I think we'll need a callback for that. Let me make a note of that. Callback for privileged ports. It's more or less just allowing. Client implementation should reject these messages. Yeah, that's fine. We know we're working on a client. If a client passes zeros, the port number, and has one reply as true, then the server allocates the next available unprivileged port. That's fine. That'll happen if we just say 0. Otherwise, there is no response. Because if they want to reply, we actually tell what the port was. So there's actually a message that we have to send back. So we need to create a struct for that. So let's see, what should we call these? Address to bind. Something like that, maybe. Remote forward request, and then comment that later. Remote forward success, which is just the bind port. And cancel request. Cancel request. Won't reply address, and so I guess it's identified by those. So we'll have to keep those around. So maybe we'll do that in this handler struct. Channel request may be received to apply to this. Okay. So I guess we have to look up the, we can probably just normalize this into a string in the way that Go likes to do address and port in a string. So maybe we will do, I don't know what data we're going to have to keep around. But you know, we'll have a string to look it up. So we'll do that for now. Cancel. Okay, I think, and that's pretty much all. We have channels. Oh, there's a channel payload. Let's see. So this is what we already have up here. local forward data. You might want to be more specific. This is channel data. When you open a channel, you can have kind of an arbitrary payload. So, of course, now I need to put this there. Actually, is there any other place that's referenced? So we would have an equivalent, and it's actually pretty similar, I think. Center channel, maximum packet size. I think those are standard part of opening up a channel, and this is custom. So host to connect, originator. So that's what we're looking at here. And similarly, we have this address that was connected, port that was connected. So that's kind of interesting, kind of useless, because all we would care about when we actually get it is the originator IP, but I guess it passes along what was connected to. That's fine. So pretty much the same data, just different names. And we could call it destination host, I guess. I kind of feel better calling it adder, though. Those are also long names, but yeah, I'm gonna shorten them. These names don't really matter because the way the unpacking works, it just does them by order, which is kind of nice. I kind of want to change this here too, but I don't. It's not really used for anything other than those. So I can easily just replace that with test adder. Oops. I don't even think these are used. Okay, so we've set up our structs, and kind of loosely what we're going to need to do. When connection comes to locally forwarded port, I guess it changed. This is not really talking about remote forwarding now. It'd be nice if it made that distinction, because I was actually confused when I first read this about which was for what directionally. Yeah, so there's not much else. It's all just kind of implied. Okay, open up a port, forward it. So that's pretty easy. So it looks like we are going to need to reference this because we have some state, and because of that, we'll probably need to set up a mutex. I mean, we could use the new sync map type, but whatever. I think I want to handle this first. Okay. Oh, that's interesting. Let's see, handle channel. This handler doesn't actually need to handle any channel because we're not getting a channel from the client. We're actually sending new connections. So we only open a channel. So in terms of forwarder, we don't need this. We really only need to handle these requests, and that should be enough, which means we don't have to register these. Right now we're hard coding our registers because it's not an open API for our people to add new handlers. Let's see. Forwarded TCP. So this is where it's kind of confusing. So direct TCP is from local to the server, so the server needs to handle those channels. But this is something only the client would implement, so we don't need to do that. Okay, that fixes that. So now we can get back here. So I guess in general, what we want to do is parse the request payload, and then actually just start listening in a Go routine. Nothing's actually, this isn't called in a Go routine to handle ordered processing of requests. So anything that would be blocking, we need to do in a Go routine from here. So we listen in the Go routine. And in that Go routine, open connections to client and proxy. So it's not much different than what's going on here, except we're going to have to go and open a connection. And we will need the SSH connection, which we don't have, but we have it in the context. So there's a bunch of stuff stored in the context, mostly because it's not, a lot of this stuff isn't, actually most of this is exposed in another way. Actually kind of built wrappers around those. The SSH server actually has its own concept of a context, which is a Go context with these helpers. And because of this weird thing, we have this kind of like different way to set values. I don't really need to get into that, but so we want access to this connections, context key connection. So connection, request doesn't have a reference to the connection. No, okay. Context, we want to get a value this and type assert it because this library created it, although it is what is it called? This is the type. It's a, oh god, server connection is a server connection, and I don't know if this is imported. Okay, good. At some point, yeah, I'm not sure, because in theory you shouldn't have to use the Go underlying SSH library. There's certain type, and then this is an implementation, so whatever, we can obviously reference it, but hopefully as the user of this you shouldn't have to ever use that. And for some of the types you do need to reference them, and so we do embedded types for that. Apparently in the new Go we can just create aliases, so they will actually be equivalent types, and that's pretty cool. And so there might be some other types that we would need to do that for. If we just like aliased all the types, then internally we could kind of have nicer code too, because we just reference local types instead of having Go SSH as a namespace everywhere. Okay, so we have the connection, which will be used somewhere here for opening connections. Right, open channel. Setting that up. Okay, parsing request payload. Yeah, something like this. So I don't know if it's called extra data. It's request payload, and then the type. So we had to create a remote forward request for our request payload. I guess it's a good name. And we don't have the ability to reject here because that's just opening up a channel. Instead, we can return a payload, and if they want to reply, a true or false. So I'm guessing if this fails, we can't really say why. So we'll just fail with an empty payload. I don't see anything in here that says otherwise. So we'll just return false with empty bytes. Maybe we would log here, but there's no great logging infrastructure for this library yet. So maybe I'll do to do log failure. So now we have request payload. We have enough information to actually start listening, which we want to do in a Go routine. I was going to say, because we had to synchronously still return if with the port and everything. So let's see. Maybe let me look up net listener. Because we're going to do something like this. So we can set up the listener and then do this in the Go routine. So actually we want to, maybe we could just do this. Create a string, can make this a stringer that combines those. Will this always work? I think so. There were some special cases, right? But I think all of those work. Like if it's empty, that'll work if we pass it along. That'll work if we pass it along. IPv6 is something that we'd have to do special. I guess we'd actually have to detect whether it's IPv6 to see if there's, I guess just check to see if there's 2 colons. I don't know. Is that a reasonable way to see if IPv6? I almost want to detect it and just not, and say it's not implemented for now, and then somebody else can do IPv6 here. Because we don't do anything special anywhere else to support IPv6. Mostly because we don't have to. I think this forwarding, dial context, TCP. I wonder, maybe I should be, I imagine this dialer actually will work with IPv6. But we're listening, so this is a little different. Although I'm actually, maybe we can do IPv6 address here. Let's actually look. Listen. Oh, so we do have to specify. Oh, if it's TCP for TCP, to only use the port. Okay, so this should actually work. It'll work with the. So wait, how does that work with IPv6 if it's a if you were to have this and then do a port, would that be colon port number? I'm not as familiar with IPv6. I'm assuming that's what it would be. In which case this should work. Payload string. Okay, if there was an error, I'm sure we're logging somewhere. No. Yeah, I guess not. Most places we can actually handle, bubble up the error, but we can't really here. Log listen failure. I guess we'll just do this again. And then we would actually do the go routine. That would do some accepting. Go. I forget if this closure, let's see, because it's going to be a pointer. This will work. Handle error. Can't really handle this error. What would we do if we can't connect? I think we would want to just stop the loop, right? And then handle this connection. Another go routine for each one. Let's see. Kind of almost just. Oh, we haven't even connected. Maybe we so we accept, and then let's see. I mean, I guess I'll just do it kind of inline here for now. So our connection is going to be doing this. We have a name conflict, don't we? SSH connection. This is a new connection. So chat disconnected. Successfully connected. Oh, look at that. I actually got notified that it disconnected this time. That's nice. Let me know if it works. If you're around, if you're watching, just say hi. Or feel free to ask any questions, really. Like, I'm just kind of like going along. But if you have any kind of feedback, let me know. Open connections to client. How do we do that? Okay, so we're naming these things. It's like the hardest thing. Just figure out how to name this stupid shit. Could go this route. So at this point, I guess we could try opening up a channel. We get a bunch of stuff when that happens. Open channel. It is actually, we would want to use the name. Nope. Yep. Nope. This one. Actually, as a string. Seems like this should go in a constant somewhere. How do we do this with the agent? Kind of worked similarly. So I'll do that. Channel type. Agent channel type. Remote forward channel type. I guess I can just call it what it is. Forwarded TCP IP. God damn it. What an obnoxious name. Forwarded TCP channel type. Open to better names. What else here? Oh, and the payload, right? So this stuff, address that was connected. Okay, so we actually need to fill out one of those. This. And luckily we don't, oh no, we do have to, we do have to marshal it ourselves. Fine. Jan data. What do we got? Destination adder. So that's going to be based on this adder. I'm going to have to split it. Let's see. I just want the port and the address separate. Maybe I'll split. If I recall, there's like a split that's specific to this for, there we go. Oh, interesting. You would do that. So in theory, we would want to wrap IPv6 in square brackets instead of just passing it through. Yeah. Yeah. Well. Shit. I'm thinking about up here when we were parsing it, and I just did this string. I guess in in here we can detect if it's strings contains, if it contains that, then we'll do IPv6. I think that's all we need to do. Okay. Nobody's saying otherwise. And so that works fine. And we need to do this split. Net split host port. Host port. Split host port. Adder string. Yeah, if error, again, basically have to just say, well, at this point, I'm kind of screwed, so this is kind of an obnoxious thing for it to fail on. It shouldn't, because it's getting an adder from standard library, but I mean, you know, we could just ignore it because we can assume it's always going to work, right? If it's not, that's a bug in the standard library. Just to get rid of this. I mean, these will be empty, and so, you know, whatever happens, happens. And then the origin we need from, what do we have? Local editor, we want remote adder. Oh, we have local adder too. I mean, that's the same thing as the listener, right? Should be. I guess. Yeah, so anyway, we do want remote adder, and we will also have to split those up. So this is dest adder, dest port, origin adder, origin port, right, as a string. Yep. So this is all pretty straightforward now. Origin adder, origin port. Isn't this fun? Just kidding. No, I mean, it does feel like this kind of program is very like, you know, the necessary stuff you have to get through. Okay, so now we have this, and then we have to serialize it. We have to marshal it using Go SSH's marshal. which is going to give us a payload byte. Apparently no error. It's just going to work. Does it want a reference? Does it matter? I think I just want to do this. I'll look at some other. I think session does a lot of this. Some marshalling. It's unmarshalling. Do we do any marshalling in here? No, that's passing a reference. Okay. I'll do that. Payload. Okay, so in terms of arguments, then we just pass this payload. We have a bunch of stuff to deal with. We have the channel. We have, whoops, we can't call it that. Then we have an actual Go channel of requests. We can call that requests. And error. And obviously, if there's an error, what are you going to do? Log failure to open channel. And return, I suppose. So now we have requests. I don't. That's interesting. I don't. So when you open a channel, now you can send channel-specific requests. So you can have global requests and channel-specific requests. This cancel TCP/IP forward, I'm assuming is a global request. Okay, it says global request. So I think we can discard all requests for this channel, which is nice. Discard requests, and now that we have this channel, we can start proxying with this connection, which is basically deconnection. Oh, because they're going to an outbound connection. Yeah, it'd probably be a good idea to close this if we fail to open this connection. So while we do that, I mean, ultimately we want to close it either way. But okay, I guess we can do that in this way. So channel close, disconnect and close. We do it that way and that way. Oops. Okay. Although, is this true? I think so. I'm trying to remember, there's a certain case where he stopped sending. If this were empty, then this would end and that would close this. I don't know if this was an error on their part. I forget. I mean, I do this so often. I call this connection joining. And it normally never looks like this. So I'm wondering if this person, because they're test passed, but this is one of those things that your tests have to like explicitly try, like a real world scenario. Let's see, when this isn't the case, because you can. Because if your input has an EOF, but would you send an EOF and not close the connection? I think it's on like pipes that you can do that. Whatever, I'll do it like this, and then we'll try it out and see if it works, and if not, we'll debug it. Yeah, so now the only thing is, so maybe it's the listener that we actually keep a reference to, because we basically want to say to stop listening. When they send the cancel. We could also check I wonder what would happen, what SSH says if it gets this failure. So let's actually, we can check this in theory. I mean, anything else could be listening on a port, but if we have a forward for it already, then we can maybe avoid this error. Maybe not. Maybe we don't want to check. I was just going to say, yeah. So after this, we'll create that forward. And I guess this will be a net listener. Oh God, typos. Forwards. String equals listener. We should lock, huh? Well, let's do that. I usually do embed it because it's like, I mean, this isn't even public type, so might as well. And then, so all this, I think that's all we want to do here. Oh, we have to return a, if they said true, which we actually handle that outside of this. The handle is garbage that I wrote. Where is it? Handle connections and then handle requests. So we get the payload, and only if they want reply do we. Wait, I think we want to reply. I guess no. If they don't want to reply, then we don't reply. So then we reply with the return value and the payload. So we'll basically just throw away the payload if they don't want to reply, but we'll return it anyway. Because we have to return something here. And what they wanted was success, assuming that there was a success. So, but if not, then that, so this should be a success. And is it just the port? So it's like I'll need this up here anyway. Let's see, this is what we're listening. These should be the same, right? This and this. I think I'd prefer to use this. I mean, if we get this far, I trust it better than whatever I had. It shouldn't matter. It shouldn't matter. So now we have the dest, and that's also used down here. But then we also use the destination port in our return thing, which maybe we can do this all in one line. Go Marshall reference. I mean, we could even just do, like in other places, just an inline type. The only thing is bind port, which is not a uint32. It's actually a string, so we're going to have a problem with that. And actually with these as well. Nobody noticed that. Which means we have to use string conversion. Yeah, which can have errors. Again, maybe I will ignore the error, because if you get a port that's not a number, what are you going to do? I mean, we already can't do much in the case of errors, so it's like, yeah, what are you going to do? Let's see. It doesn't matter up here because it's already going to convert it to a string. So it's really just when we're splitting it out and we put it into these. So we'll call this port string. And call this des port. And we'll have to do the same with origin port. Did that too, like that? Yeah, we do. Okay, so that's fine. And down here we say des port. I think. Yeah, bind port, des port. That's going to return, might need to be typecast. It's going to be an int. We need it to be a uint32. So we'll actually, we'd have to do that here too. I think this is all we need to do. Yeah. Okay, so that's pretty much how we'll handle requests to do the forwarding. And when we cancel, is there any like special, like what it needs? Canceling. Channel open request may be received until a reply to this message is received. The channel open request may be received until, so that's on the client side they're saying. Okay. Basically, I just want to look this up. Oh, this is silly. There we go. You guys are missing all kinds of stuff. Now, this is going to block. This is what is done. Oh, it's also not done in coroutine. I mean, yeah, it shouldn't block for very long, so I'll be okay with this. Here we want to do a check. We have to parse how we gotta look this up. by doing this. My comments are becoming non-existent. I might as well be consistent. Request payload. Okay. So we parse the request payload, but this is a cancel request. And oh shit, and that's a different type. So we're not going to get this on it. That's a bummer. I guess I just want to make that a standalone function, or I don't want to just, I mean, I could copy and paste it, but yeah, it doesn't actually, shouldn't this actually have something like this? The opposite of split? It's join. It's taking strings though. That's fine. Cool. So this is basically already done. It even does that IPv6 check. I just have to convert this to a string. It's easy enough, right? So we'll call it adder net join host port. We've got bind adder, and then bind a request payload bind port. It's probably going to want this to be an int, and that's it. We say adder. So we basically want to do the same thing down here. And just to make sure, because we actually don't want those, if there's any differences when going through here, just to be sure, we're going to use adder there as well. So either way, we unlock, and then if okay, then we close the listener, and I don't know what it expects. I guess either way it will return true. It doesn't actually say whether something bad will happen or what the meaning of returning false would mean if it canceled. So I'm just going to always return true. Because, you know, nothing bad happened. You wanted it closed? Well, it's no listener in the first place. Okay, so some things here. What are we looking for? Origin port. Origin port, that's a typo. And what's the problem here? Can't. Oh, we can't? Why not? What does it want? That seems like the same type to me. Type SSH. Oh, I'm saying request, not request. Again, sort of a typo. Well, it all compiles. so has no coverage. But in theory, it could work. We have no idea. It's been about an hour, but I really want to finish this. At least have like working. Like it can like sort of not work, but just have basic functionality. So I should set up an example. We'll call it SSH remote forward. So because we're registering this all the time, it sort of doesn't give you a choice of whether or not you will allow it. So for now, if you were to just do a regular SSH server, it will do remote forwarding. There's no callback or anything. That was my note, was to create a callback to see whether or not you would allow it. I'd probably want to do something like, a PTY callback. I'd do like a remote forward callback. I'm probably a local forward callback because, yeah, we're just like arbitrarily handling those, and that's not necessarily what you want if you just want to make like a specialized session handling server or something. So actually this remote forward, I'm going to come back to it, but in theory we could actually just run this and it would do forwarding. There's no logging, but if we don't get any panics, then that's probably pretty good. So yeah, I'll go into examples. This was simple. Go run simple. Okay, so we have, probably want to do SSH keygen remove localhost SSH localhost anything. It says hello user, and then God, how do you do forwarding? This is interesting because it is often done in combination with a session, and so as long if the session ends, then it won't be able to open connections. So that's something that we need to look into. If the client disconnects, we also need to close any listeners associated with that. So I think there's going to be a little bit more work in kind of cleaning this up and handling it properly. But for simplicity's sake, okay, I'm going to actually just do a where we'll say remote forwarding available ... and then we'll just kind of like sleep indefinitely. I'm not sure if that'll work, but we'll try it. Go run. Because it's generating a new host key every time. Okay, so if I run this, okay, it just blocks. I didn't even put it on a new line. Not that it matters. Oh, I can't even disconnect. Sending signals. I guess, yeah, That's obnoxious. I wonder if it was not handling control interrupt. If I run, so I'm going to do this. If I run it with a command, if it'll work. Control C, yeah. Because it allocated a terminal, and so whenever I would do Control C, it would actually send that as a character, which would then process on the other end. So, if I do this, or tell it to explicitly not allocate a terminal, I'm not sure. I'll just, specify command. That's the easiest way to get to not allocate a terminal. And then we actually have to do the forwarding stuff, and we'll see how this works. So I always forget, it's like -R, but what is the format? So SSH remote forwarding. Sure, explain it to me. It's local forwarding. Remote. Okay, so this is the local. Specify which port on the remote. 9000. Well, that's weird. It's almost first on the local host for my local machine and the local port. Oh, okay. I guess you can specify an address here too. I was just assuming. Okay, so this is the remote port, and then this is it's going to connect to. All right. Well, let's do. We'll just create some more sessions and have netcat listening on here. 9000. And then I'll try connecting to localhost 9000. Hello. Close that. Close this. I'll turn this on again. We'll do this, but we'll say R. And on the remote side, we'll listen on, which is the same side because we're running this locally, 10,000. And I'm going to connect to localhost 9000. Now, this could trigger panic. It seems that it did. Okay, we didn't actually set up the map. That's an easy one. I guess we just do that immediately, because why not? Yeah, if do we want to lock in this process, maybe. Map of string to net list. Okay, so first bug found and probably fixed. So now we do this. Then we run. This is still going. And we want to run this. Okay, so far so good. No connections made, so we should be able to connect to 10,000 and have the connection go through. Didn't work. Server requests forwarding for unknown listen port. Server requests forwarding for unknown listen port. What does that mean? Maybe if we turn on robustity. Oh, look at that. Remote forward failure. So it does it up front, and depending on whether it gets true or false, it'll know. And so, warning, remote port failed for listen port. So what's the problem? We don't know. I guess we can start instrumenting this with some logging. We can first just start logging to see that we got in here. So request handled. Yeah, so I've got the request. All right, so I'm assuming it's doing TCP forward, and any of these falses could have happened. So I'm going to instrument all of these for now. Log parse failed, and this is, maybe I'll even throw in the error. Log parse listen failed. This really doesn't matter, but I will do it anyway. What's another failure that we could accept? Failed. Open channel failed. Oh, I got disconnected again and reconnected. What else here? Parse failed. Okay. And if we get to the end, we'll just log just that forward accepted, I guess we'll say. Boom. Boom. What do we got? Forward accepted. Wait. So it worked this time when all we did was add some log statements. That's not great. Well, I guess let's see if it actually works. Failure forwarded TCP/IP. Open channel failed. Rejected. Administratively prohibited. Administratively prohibited. Why? So it's forwarding available, remote forward success. So in theory, it's listening. All remote forwarding requests processed. Good. And then it's saying that there is a channel open, right? That's kind of what we expected, right? I don't know why it's doing client request forwarded. TCP/IP. Is this the wrong channel type? Because it looks request forwarded TCP/IP. Did it do this already? Did I get the protocol wrong? Kind of confused. Server requests forwarding. The server is requesting forwarding. No, we're not requesting forwarding. For unknown listen port 10,000. Okay, so what am I missing? When a connection comes to a port for which remote forwarding has been requested, a channel is open to forward the port to the other side. Right? Forwarded TCP/IP. And that's what we're sending here. Forwarded TCP/IP. This red is obnoxious, but forwarded TCP, and it doesn't like that when I open that connection. Notice it worked only after it printed this. I wonder if that's it's a race with something else. Maybe setting up the handlers? I'm not sure. Okay, so client input channel open forwarded TCP. Yep. And then for some reason it does client request forwarded. Listen. Local 10,000. When did that? I need to do this again to make sure. Yeah, to make sure. Let's start over. So clean up. Remote forwarding success. Okay, so this is still going. So it's then when I connect to 10,000, so I'm actually connecting to the server, and then it connects locally. Okay, so server requests forwarding for unknown listen port 10,000. So is it that this payload has the wrong destination address? That's the 10,000, right? Or sorry, this. To remote port, yeah, the origin and the destination. Maybe I'm missing something. I thought this destination port is the port that I'm listening to on the server, right? Because it doesn't know what I want to connect to, but the client seems to be like, I don't know this listen port. Even though it's like, oh yeah, listen port 10,000. Connect to 9,000. It's as if I'm assuming maybe, possibility, is that it expects this to be 9,000 because that's a port that it knows about. I don't know. Remote forwarding success for listen 10,000, connect to localhost 9,000. Server request forwarding for unknown listen port. Request forwarded. See, the way this is framed seems like it's doing something like it's getting a request to forward, right? That said, okay, forwarded TCP IP. Open channel, forwarded TCP channel type, destination header. The address that was connected, the port that was connected, the originator IP address. Implementation must reject these messages unless they have previously requested a remote TCP IP port, right? So I did have it request. God, leave me alone. I did have it request that. See, listen, 10,000. So when a connection comes to a locally forward TCP port, so this is something different, but maybe it's not, because interpretation of these can be wrong. The following packet is sent to the other side. So when a connection to a locally forwarded TCP the host to connect and port to connect specifies where the recipient should connect the channel. Yeah, I think this is unrelated to remote forwarding. So what's TCP forward, address to bind, port number to bind. Maybe I should also dump out some of this. Like print this out. And just to be sure. Also, what's going on with these? This is happening outside of this routine, but that should be fine. Open channel, unless open channel needs to, no, there's nothing to reply to. I'm thinking about my my handler code here. So we've got some handlers, and there's no others, and this might not have to do with anything, but I wanted to see. So if I call handle request true or false. Okay, so it only goes to one, so it's not like going through a bunch. Okay. I guess we'll run through and see if we get anything from the structs that we're spitting out. I mean, I'm not doing anything wrong here. This saying that administratively prohibited is really just it saying that the other side rejected it. Right, remote Forwarding means, hey, listen on 10,000, and then when that connection comes in, I want it to go to 9,000. Right? Localhost 10,000. That is the remote forward request. Yep. Address port. Address port. So it is now listening. This guy is listening on 10,000. We know this because we can connect to 10,000. Oh, it's already serialized. And we get the same thing. Server request forwarding for an unknown listen port. So again, I don't know, why is it saying it's the server requests forwarding? Again, it's very confusing because there's some can be ambiguous language here, but to me, the way that sounds like is the server says, hey, client, will you start forwarding, like doing local forwarding? But yeah, this is request forwarded TCP/IP, failure forwarded TCP/IP. I don't know, man. Does this say anything else? Like, this is as open SSH specific. This has nothing to do with it. Only do port forwarding. Imagine you're on a private network where 9,000 is the local port. Okay. 9,000 is the local port, and this is connecting to the on the remote side. This was well as the syntax reads, specify the port on which the remote server will listen. 9,000. Remote server listens 10,000. And that makes sense because that is what I got on the other end. I should actually say, hey, I'm listening. Not here, but here. Listening on destination port. String, why not? And we know we get all this. It would be nice to print this before, but then I have to fucking assign it to something. I mean, this is probably, I don't know. I'm curious about this. Let's see. But this should tell me what that is. So. Okay. Yep. Forwarding. Remote forward success for listening on 10,000. And it's listening on 10,000. All right. So now I should be able to connect to 10,000. But same thing. I don't know why this still really bothers me, because this doesn't seem right. Does that happen anywhere else? Client request forwarded TCP/IP. Server request forwarding for an unknown listen port. Unknown listen port. Like, like you don't know that you told it to listen on 10,000, or you locally are not listening on 10,000, you know? Failure, forwarded TCP/IP, channel type. Forwarded TCP/IP. TCP/IP forward is the request. Cancel TCP/IP forward is the request. Forwarded TCP/IP is the channel name. Or type. Forwarded TCP/IP. God damn it. Is there some way I can turn off this fucking... leave me alone, Red. I really don't care that I don't have coverage right now. Please stop. I'm getting pretty frustrated if I don't get this soon. I'm just gonna do this. And there shouldn't be anything surprising, but okay. This is what it's sending. Is it the difference between this and this? That could be interesting. So maybe we are on it to something here. Shit. Localhost. Wait a minute. Localhost. Foobar. Okay. Good. Yeah, it's saying it failed. Okay. Okay. And then this seems a little odd. Destination address. No, it shouldn't matter because this is just what the incoming. Where did this come from? Destination address. destination address. I mean, that's interesting. It did change it. Like, I think, yeah, it comes in as localhost, and so then here we're like, listen, localhost, and then I'm saying link adder string, and it's saying 127.0.0.1. And so when a connection comes in, it's like, hey, 127.0.0.1. But that could be, the client could have written down, because it sent localhost, so it could have written down on its end, hey, localhost 10,000. So we might actually want to, in this destination, make sure it is actually localhost instead of what the listener says, because the client might not have that in its little lookup dictionary. So I guess in all of this, I still have access to this, or I can in closure. I'll just do this twice. Yep, that's true. I'm not using it. Maybe this will make a difference. Oh god, start is over. And this, kill that. Now we run this. Now we do this. And do this back to localhost. Remote forwarding success. It's listening. Connecting to localhost 10,000. Oh shit. Hello world. Hello world. Oh hi. Oh hi. That was it. That was fucking it. Jesus. Yep, the client said, hey, listen on localhost 10,000, and I came back saying, hey, something wanted to connect to 127.0.0.1 10,000, and the client's like, what? That's not what I asked for. And so it would reject those connections. That is good to know. What's this? Connection failed? In progress. Channel 1. I don't know what this is about, but it's working. If I were to close this, then that closes. If I set this up again, I should be able to connect to it again. Hello, hello. And if I close this end, wait, which end did I close before? And I close this end. That closes the connection. And everybody over here is pretty happy with all that. Okay. I don't think I need verbose anymore. So yeah, it turns out that printing out this struct actually helped solve the problem. So it's a good thing I did that. Let's see here. Okay, leave me alone, leave me alone. Next time I hit save, it's going to do it again. I'm not sure how to do a cancel, but guess we'll catch that in tests. Which is, I don't know if that's fun to stream. I'll do a poll and see if anybody wants to see me write tests for this. But as far as what we tried to accomplish tonight, I think we succeeded. The only problem is ultimately, no, yeah, this is ultimately what I'm going to need for command IO. So, so I'll take out these print statements. We've got to-dos in there. And we also have the issue of, I should add a callback. Which gets into some other complex stuff. We need to change the API. Callback for determining if remote forwarding is allowed. Because right now it's just hard-coded to accept it, and that is not what we want in both directions. Although, yeah, so even though we do have a handler for local forwarding, the author of this did at least create a callback for that. So I guess we can say to do remote port forwarding callback. Okay. I guess I can try this one more time real quick before. And we still have to yeah, what happens? This will work where we say NNT, which I'm not sure, will cause not to allocate and only do the port forwarding. I'm not sure specifically what these do, but we can try them and see if it works. In which case, we shouldn't have to do this. Okay, we still have a print somewhere. And here, yep. And of course, if I close this, these are closed. Okay. Okay. Okie dokie. So we changed some files. What did we do? Yep. Got rid of forwarded TCP. Wait, what? Oh yeah, because forward TCP is not a channel handler. We added a bunch of structs. We changed those structs, yeah. And we added a bunch of structs, and then we wrote some handler code. Okay. Working remote forwarding. So this is going to go to the remote forwarding branch. And if anybody wants to play with it, it is available up here. And we still have to write some tests for this and do this callback business. And if anybody else sort of reviews this in the meantime or watches this and catches anything that I didn't catch, let me know so that we can get that in. But once tests are in, I feel pretty comfortable merging this or opening up a PR to merge this into master and letting people use it. So that's it for today. It was a little bit longer than I expected, but we got it done. So that feels good. If you want, I stream every week. I'm trying a new time this week, so it's a little bit later. I think I can do it. So it's 6 p.m. Pacific time. It's 8 p.m. here, and yeah, I'll try the same time next week to see how it goes. I don't know if I got, I did it to see, if more people could tune in. Although I didn't tweet about it this time, so I tweeted about it beforehand, but you need that reminder to tune in immediately. Okay, well, that's about it. Thanks everybody for watching, and subscribe to my YouTube, and you can find out other stuff that I post and other times that I stream. This is just my regular time. And follow me on Twitter, and I do polls and stuff to see what I should stream. So that's about it. Thanks for watching. See you guys later. Bye.